Seventh graders, let's go ahead and get going on this midterm study guide. The first one has 5 to the 5th times 5 to the 6th. I'm going to blow this up a little bit just to go ahead and see a little better. There we go. And now we see that, yes, we have 5 to the 5th times 5 to the 7th. Well, we know it's really 5. When the base is the same, we can add the exponents. So this is 5 plus 7. That equals 5 to the 12. All right, let's go to the next one. This is a fraction. Every fraction is a division problem. So when I multiply, I can add. When I divide, I can subtract. So this is really 2 to the 4th power minus, and always remember, even if you don't see one, there's a 1 right there. All right? So that's going to equal 2 to the 3rd power. All right, over here, we remember that 0, anything to the 0 power is always 1. Okay, and anytime you have an exponent, it affects everything in it. So this is going to be 1 to the 5th power over 6 to the 5th power. All right, times 1. Now, anything times 1 is itself, so my answer has to be 1 to the 5th power over 6 to the 5th power. Do not leave the answer as 1 to the 5th power times 6 to the 5th power times 1. When it says, write your, use the laws of exponents to simplify. Simplify means no fractions, no parentheses, no parentheses, and you can't have like terms. And these are like terms, these are numbers. They don't have an X or anything after them, so I can multiply them. All right, going to number 4, we got 0.35 to the 4th power to the 3rd power. When I have parentheses with a power to the power, I multiply my exponents. So this is 0.35 with 4 times 3. Now it's going to equal 0.35 to the 12th power. Out over here, we got 12 to the 8th power, 12 to the 3rd power, 12 to the 4th power over 12 to the 2nd power. I'm going to operate off the top first. 12 to the 8th power times 12 to the 4th power is 12 to this 22nd power. Oh, I'm sorry, 8 plus 4 is 12. I don't know where I got 22nd from. 12. And then 12 to the 3rd power times 12 to the 2nd power, that's going to be 12 to the 5th power. Now we have a division problem, which means we can subtract. This is going to be 12 to the 12 minus 5. Well, 12 minus 5 is 7. So this would be 12 to the 7th power. All right, let's go ahead and go to number 6. You send an email with a file of 8 kilobytes. 1 kilobyte is 2 to the 11th byte. What is the file size of your email in bytes? Well, I know I've got 8 kilobytes, and that's 1 kilobyte is 2 to the 11th. Which means I got to take this 8 and turn it into a base of 2. All right? And now that tells me that I'm going to multiply by 2 till I get to 8. 2 times 2 is 4. Then 4 times 2 is 8. That tells me that 2 multiplied to itself 3 times will give me 8. So this would be 2 to the 3rd power. Now I've got to turn this into a fraction. Okay? That should be multiplication, I'm sorry. Which means I'm going to take this 2 to the 3rd power and put it underneath 2 to the 11th power. Now this is a fraction. Every fraction is a division problem, which means I'm allowed to subtract. This is 2 to the 11th power minus 3, all right? And this is going to be 2, well, 11 minus 3, that is 8. All right, let's go to number 7. Complete the statement using less than, greater than, or equal to. And this one, I realized I got 4 to the 1 and 1/4 and negative 4.1. I know when these both come out, they're both going to be positive. So it should be 4 and 1/4, because these are absolute value signs, and that means how far they are from 0. And that means I'll always get a positive number, because distance is always positive. Now I got to see what is more, 1/4 or 0.1. Well, when I think of 1/4, I remember that 1 over 4 is a division problem. 1 divided by 4. I bring my decimal point here, add a 0, and 4 goes into 10, 2 times, excuse me. That's an 8, and I'm going to get a remainder of 2. And then 4 goes into 20 5 times. So that means this is 0.25. So this is going to be 4.25. You see, we took the fraction, we divided it out, and replaced the fraction with the decimal part, or decimal answer. So now we have to ask ourselves, what is bigger, 4.25 or 4.1? I think the answer is obvious. 4.25 is greater than 4.1. So my sign will be greater than. All right, we're up here. It says select all the equivalent, all that are equivalent to negative 1.25. When I come over here, I see negative 1 2/5. Well, I can check the 2/5 equal 0.25 by taking 2 and dividing it by 5. Every fraction is a division problem. When I do this, I bring my decimal point over here, my 0 here, and I see this is 0.4, which is not equal to 0.25. This one does not. It is not correct. All right, let's try the next one. This is a negative 1 1/4. So I know the negative 1 is good there. Now I've got to take 1 and divide it by 4. When I do this, I'm going to put the decimal point here. 4 goes into 10 2 times. My decimal point is here. This will give me an 8 with 2 left over. When I put the 0 there, 4 goes into this 5 times. So that is going to be 1.25, negative 1.25. So B will be a correct answer. Let's go to C now. C is 1 divided by 25. Well, we got 1, we're dividing it by 25. I already know this is going to be wrong, because over here, 1 divided by 4 is 0.25. So there's no way this is going to work. In fact, when I put this here, I can only put a 0 here, and the 25 goes into 100 4 times. This is 0.04, which is not the answer. D, we've got negative 1 and 25 over 100. This is going to work perfectly. I know 25 over 100 is 0.25, but we'll check it out just for argument's sake. We're taking 25, we're dividing it by 100. Everyone sees the decimals here, and when I put my decimal here, my circle here, 100 goes into 252 times. 2 times 100 is 200. That leaves me 50, and then we add another 0. 100 goes into 500 5 times. So 0.25 is correct. We already had the negative 1 sitting in front to match our negative 1 there. Last one, we've got negative 125 over 100. Well, this is going to equal, let's see, 125 over 100, or divided by 100, excuse me. Well, my decimal is going to be here. I know 100 goes into this 1 time, leaving me 250, or excuse me, 250, or 25. I'll put a 0 here. 100 goes into 250 twice. And with my 50 left over, I'll have to add a 0, and 100 goes into 500 5 times. And look at that, 1.25. So E is also correct. Let's go to number 9, write a fraction. 7 over 11 as a decimal. Well, this is easy. We're simply going to take 7 and divide it by 11. It says to use bar notation if necessary. It just might be. If I take 7, divide it by 11, I have to go ahead and put a decimal here, which means I'll be going to 70. So I've got 11 going into 76 times, because that'll give me 66, which will leave me 4. Now I'm going to have to see 11 goes into 43 times, with 33. That leaves me 7 again. And now I see it's going to go ahead and do the same thing over and over again. Which means I can say that this is 0.63 repeating. Remember, the bar goes over the 6 and the 3 because both are repeating. All right, evaluate the expression. I know this one here is, I've got to go take a fraction and divide it by a fraction, or divide it by a whole number. So this is a fraction and a fraction. I'm going to have to go around the world. 7 times 3 is 21. 21 plus 3 is 24. So this is really 24 over 7 divided by 6. Now I'll do keep, change, flip. I'll keep my 24 over 7. I'll change the multiplication and I'll flip. Remember, this is 6 over 1, so this will flip to 1 over 6. Now I can reduce because 6 goes into 24 4 times. 6 divided by 6 is 1. 24 divided by 6 is 4. Well, now I got 4 times 1, and that equals 4. And I got 7 times 1, and that equals 7. My answer is 4 over 7. All right, let's go to number 11. Number 11, we have us, well, it's a multiplication problem and then addition. You might not notice the multiplication problem because that's a negative with a parentheses and a negative. But remember, whenever a negative is outside of a parentheses, you have to multiply it to what's in the parentheses. Well, negative times a negative is a positive. So now I could rewrite this problem as negative 2 over 5 plus 4 over 3. I have to get a common denominator. I know that I can multiply 5 and 3 to get 15. So I'm going to turn this into a 15 for my denominator. Now 5 times 3 is 15, and 2 times 3 is 6. I know 3 times 5 is 15, and 4 times 5 is 20. Remember, there's a negative sign here, so this would be a negative 6. Now we can combine these. Well, 20 minus 6 is 14. And 15 stays the same since it's our denominator. And our answer must be 14 over 15. Now we're coming over here with a division problem. Once again, we use keep, change, flip. We're going to keep the first one. We're going to change a multiplication, and we're going to flip the second one. This will be a negative 4 over 3. I see there's a 3 on the top and 3 on the bottom. I can go to reduce these. 3 divided by 3 is 1. So now I've got 1 times a negative 4, that's negative 4. And I've got 8 times 1, and that's 8. So my answer must be negative 4 over 8. But wait a second. Remember, 4 over 8 can be reduced. Both of them are divisible by 2, or actually by 4. That's going to equal negative 1 over 2. Final answer. All right, number 13. I see I've got an absolute power here, and I've got a negative 1/3 out here. I know I'm multiplying this to this, but I got to do what's inside this bracket first. So I got a negative 3 to the second power. Remember, that second power is not in the parentheses with the negative. So this negative is going to stay here. I'll put the absolute value there, the negative stays, and 3 to the second power is 9. Because remember, this is 3 times itself twice. 3 times 3 is 9. Now we got negative 9 minus 18 divided by 0.3. All this is in the absolute value sign. And we have the negative 1/3 outside. I still got to work out inside here. I know 18 divided by 3 is 6. And I can rewrite this to negative 9. This is a negative divided by, well, I forgot there's a 0.3. So I'm thinking this is going to be possibly bigger. Let's use our calculator here. All right, I got 18 divided by 0.3. That's going to equal 60. Wow, okay. So this is going to be negative 60. And then I have my absolute value sign here. Now, negative 9 and negative 60, that's going to give me, remember, when my signs are the same, I find the sum. So this would be 69, negative 69. The absolute value signs now go away, making this just a regular 69. And I have 69 times negative 1/3. Negative 1/3 is like dividing a number by 3. So this tells me 69 divided by 3 will give me 23. And that'll be a negative 23. All right, and I'm just going to double check. 69 divided by 3 is 23. And a negative times a positive is a negative. All right, let's go on to number 14. All right, number 14 says to simplify the expression. When I simplify this, I realize that I have two numbers on this. There's no equal sign here. Hold on one second. Gave myself a little more room to work. That means I'm combining these terms. I got 2.5x. Well, you know what? I like stacking things better, so I'm going to teach you how to stack here. I'm going to move the like term. This is negative 4x, so I'm going to take away 4x. From 2.5. In all actuality, I can probably do this even smarter. I'm going to move the 2.5x, okay? So this is going to be plus 2.5. Looks like there's very little room. I'm going to rewrite my problem over here. We've got, let's see, negative 4x plus 2.5x. As far as numbers goes, we got negative 4 and we have plus 6. These are our like terms. Well, 6 minus 4, that's going to be 2. And let's see, negative 4 plus 2.5. Well, when my signs are different, I find the difference. So 4 minus 2.5 is 1.5. My x stays here, and I keep the sign of the bigger number. So it's a negative 1.5 plus 2. Select all that are equivalent to this expression here. Well, when I'm subtracting, I know all of these numbers are going to become the opposite. So this is really going to become a negative 3x and a negative 5. So I'm going to scratch this out and put a plus sign here. Okay, well, actually, the negative stays here. So now I can combine these terms. I've got, well, sorry, I had to sneeze. I'm going to take my like terms. First, I'm going to see, do I have this here? Negative 5.2x plus 8 minus 3x minus 5. A definitely works. Let's look at the next one. We've got now when I combine these, will I get this answer? Well, negative 5, I'm going to put a negative 5 over 0.2x and combine it with a negative 3x. Together, that'll make a negative 8.2x. All right, and I do have a negative 8.2x here. I do this because when my signs are the same, I find the sum. So I add these together. Next, I'm going to have 8 minus 5. And let's see over here, 8 minus 5 will give me 3. That doesn't work because this is 13, so that's not going to work. Over here, though, I do have a negative 8.2x plus 3. So that will work on this one. Negative 8.2x. This is a positive 3. Are there any others where it works? I know this one doesn't work. This one is 5.2x plus 3x. And this is a minus 3x, so that doesn't work. This one down here is a negative 5.2x minus 3x plus 8 plus 5, and this is a minus 5. So this won't work either. Just A and D were my answers. Number 16, are the expressions equivalent? Explain. Are these expressions equivalent? Well, let's find out. If I solve this part over here, will it match up to this one? Well, 3/4 of negative 4x. Remember, I can say this is over 1, which means I got a 4 and a 4, one on top, one on the bottom, right? I can cross this out, turn this to a 1, a negative 1. Now I got 3 times negative 1, and that's going to be negative 3x. That's 3/4 of 8, okay? I can say that I have 8 over 1, then I have a 4 and an 8 here. 4 divided by 4 is 1. 8 divided by 4 is 2. So this would be 3 times 2, which would be plus 6. Then it says plus x. They want to know, does that equal negative 2 times x, which is negative 2x, and negative 2 times negative 3, which is a positive 6. Well, over here, I know I got negative 3x plus x. That is, when my signs are different, I find the difference, which means I take the big number minus the small number. That's going to give me a 2x. And I keep the sign of the big number, negative 2x. And then I have plus 6. And so is negative 2x plus 6 equal to negative 2x plus 6? Absolutely, yes. My explanation is my work. Number 17 says, use properties of equality to solve this. When I do this, first I got to distribute. So I'm going to take 1/4 and times m. That's going to be 1/4 m. I'm going to take 1/4 times negative 16. Well, I can pretend this is going to be over 1. 4 divided by 4 is 1. 16 divided by 4 is 4. So now this is 1 times negative 4. So this is going to give me negative 4. And now this is going to be equal to 3. All right, now I've got to go ahead and get rid of this negative 4. The only way to get rid of the negative 4 is to add 4 to it. Whatever I add to one side, I add to the other. Now I have 1/4 m is equal to 7. 3 plus 4 is 7. Now to get rid of this 1/4, I will multiply it to its inverse, which is 4 over 1. Whatever I multiply to one side, I multiply to the other. So I'm multiplying 7 times 4. These cancel out, which leaves me m. 7 times 4, that's 28. So my answer is 28. All right, let's go to number 18. Select the correct graph for the solution. We got k divided by negative 6 is greater than 4.1. To get rid of dividing by negative 6, I'm going to have to multiply by negative 6. Whatever I multiply to one side, I have to multiply to the other. Well, my negative 6's cancel out, leaving me k. But because I multiplied by a negative number, I have to turn this symbol in the other direction. This is no longer going to greater than, it's less than. And now I got to see what is 4.1 times negative 6. Well, 4.1 times negative 6, that's going to give me 24.6. So this will be equal to negative 24.6. So now that I know that k is less than negative 24.6, I'm going to write it over here, k is less than negative 24.6. I'll look over here, where do I see 24.6? Well, we're going negative, so this is going to be about 24.6. Remember, k is less than this, and this is all the numbers less than. Well, A has to be my answer then. This wouldn't be it because this is showing the numbers getting bigger this way. I'm looking at negative number here. This is negative numbers, but this says k is bigger, so A was correct there. Let's go to number 19. Number 19 says find the unit rate. To determine the rates are equivalent. I got 0.8 kilometers for every 2 meters. I can put that in my calculator pretty easy. And that's going to be 0.8 divided by 2. That gives me 0.4. So this rate is 0.4. We do the same thing to the one down here. Cancel out now 0.2 divided by 0.5. And look at that, 0.4 again. So, are these equivalent? Yes, they are. They are both 0.4. All right, going to number 20. At the farmer's market, apples cost $8 for 5. Sorry about that. This is a mistake. There we go. It should be cost $9 for 4 pounds. All right. And as you can see over here, the cost is $9 for 4 pounds. Complete the table to find the cost per pound. To find out what 1 is, I'm going to have to take 9 and divide it by 4. 9 divided by 4 is going to give me 2.25. So that means that's 1, 2.25. Some of you are thinking, Mr. Mendes, you told us you had to do 1 divided by, 4 divided by 1, then multiply to this number. There was no number here, okay? So I had to take this number and divide it by this number, okay? Because I know if it costs me $9 for 4 pounds, if I divide 9 by 4, I'll find out what's 1 pound. All right, now that I know what 1 is, I can find the rest of these. Because if 1 is 2.25 and I want 6, I'm going to take 2.25 and multiply it to 6. And that's going to give me 13.5. So that's $13.50. Now to find out what 18 is, well, I'm going to have to take 18 and divide it by 2.25. That's going to give me 8. So $18 will give me 8 pounds. All right, I'm going to fix that 8 so it's a little bit more like an 8. Sorry about that. All right, and now it says graph the table. Well, if I graph this table, I see that it starts at 2 and then 4.5. So I'm just curious, what would it be if it was 2? I would have to take 2.25 and multiply it to 2. And that equals 4.5. Look at that right there. So for every 2, I'm going to have 4.5, which means at 4 will be 9. At 6 will be 13.5. This is going to be one of the easiest ones to do. I'm just going to get my line right here, start here, and go straight up the center of these. And now it says use the graph to find how much would it be for 15 pounds. Well, 15 pounds is going to be sitting about right here. So that means it's going to be about right here, right in between these two. Ooh. Well, right in between 36 and 31.5. There is a way I can find the answer much easier though. Remember the equation that I gave you guys, y is equal to kx. Now, x is over here, y is over here. So what we're trying to do is find out what k is. K is what 1 is, and 1 was 2.25. So we can say that y equals 2.25 times k, or x. And they're saying x is 15. Says how much is 15 pounds? The pounds are down here. So this is 15. And now I can say, what is 2.25 times 15? 2.25 times 15 is going to give me 33.75. So 15 pounds is going to cost me $33.75. All right, let's get to our last one. 1 kilogram equals 33 pounds. To complete this conversion, justify units. Round to the nearest hundredth if necessary. Well, if I do this, and I know that 1 kilogram is equal to 33 pounds, and I want to know what is 9.2 pounds, I'm going to multiply this to 9.2. Whatever I multiply to one side, I got to do the other. Well, I know this is going to give me 9.2 kilograms. Now we got to find out what is, and this is a multiplication sign. Sorry, I shouldn't use that. I'm used to using different signs in front of you. And when I bring my calculator over here, I'm going to take 33 times 9.2. That's going to give me 303.6. pounds. So my answer to this is 303.6. That was all of them. Didn't take that long, but about 32 minutes. And hopefully that's how long it'll take you to take that midterm. Good luck, and I'll see you in class.